Hello and welcome to this v0.4 version 0.4 video tutorial. And in this video tutorial I'm going to cover how to set up a natural ventilation airflow network within NV for simulation in EnergyPlus. So I've got here the two zones I set up in a previous video tutorial, and each zone has two windows in it. And I'm going to set these windows up to be airflow surfaces, points where air can enter or leave the zone. And it is important to remember that once you have specified airflow surfaces within one zone, then all zones within the model have to have at least two airflow surfaces, or it will cause an error when it comes to EnergyPlus simulation. So each of these zones has two windows in. So if I set all these windows, two per zone, to be airflow surfaces, that should be fine. But I couldn't do it to one zone and not the other, or I couldn't do it to one zone and have only one airflow surface in another zone. Each zone has to have at least two airflow surfaces if we're going to do a natural ventilation network. So I can come into edit mode here, and this material here is my external windows material. Now, as that material is associated with all the windows and I want all the windows to be airflow surfaces, what I can do is I can simply change this external windows material into an airflow surface. Now that is a material change, so I have to re-export my geometry and then re-export the context. Let me just come back into a default here, re-export. Oh, I've got a bad node in my MV network. Yeah. Once I've changed the material here, once I do geometry export, it updates these nodes within the MV network. And we can see that both zones have gone red and we've got this new control node. Now these zone nodes have gone red because we now have new sockets that need to be connected and aren't connected. And they are our subsurface flow sockets associated with each window of each zone. We also have this control node that specifies some parameters, some overall parameters for the natural ventilation network. So we're not pushing air around the building in any sort of mechanical way, so multi-zone without distribution is fine. Multi-zone with distribution is when we're using a mechanical system. There isn't really any capability within the v0.4 at the moment beyond simple mechanical systems to simulate mechanical ventilation, so it's generally multi-zone without distribution that we want. We can specify the flow that comes in or leaves the building through these different airflow surfaces is defined by the pressure conditions outside the building to a large extent. And those pressure conditions outside the building, they can either be calculated automatically by EnergyPlus, or we can input through a wind pressure coefficient array. But I'm just going to use the inbuilt EnergyPlus calculation for the moment. And when we pick this one, some of the options, like whether it's a low-rise building, the azimuth of the axis of the building, axis ratio, for example, becomes important. And refer to the EnergyPlus input-output manual for a better idea about what these options mean and what the correct setting might be for your particular situation. But that control node just sits there, doesn't need to be connected to anything, just defines the overall airflow network parameters. So in here, now we can specify, or we can connect these sockets to a node that defines the characteristics of that airflow opening. So it's in airflow link nodes, and it's a subsurface flow node. Because our airflow surfaces are associated with a window or a door, something that can open effectively, it is this subsurface flow characteristic that we require. So these subsurface flow node sockets are green, and these subsurface flow node sockets are green. If I was to add a surface flow node, which I'll cover in a minute, then those sockets would be red. So I can connect, if I want the opening characteristics of all the windows to be the same, I can simply connect this one node to all the sockets. So now all the windows are defined by what happens in here. So I can specify that it's a single opening or a horizontal opening, effective leakage area, etc. Again, look in the EnergyPlus user manual for details of those options. I'm going to keep it a simple opening. I can say the maximum opening is 0.9. I need to set a control for when the window's open. Now that control can be inherited from the zone, which currently has no control type, but it can be set to constant, so the windows are always open, or it can be set to temperature, where it's temperature dependent, but we can also specify that control at the opening level. So it doesn't matter what we set for the zone, these are controlled themselves. So I'm going to set control to temperature, and I need then two schedules. So if I add a schedule node, and I just copy that, I need a ventilation availability schedule, and this defines when the windows can be opened. So you might have a situation, for example, where you are modeling the ground floor of a property, and irrespective of the temperature, you wouldn't want the windows to be opened at night. So you could specify in here that they couldn't open at night. And in fact, I might do that now. So I might say for all days until 8 o'clock in the morning, the windows have to be closed. Until 8 o'clock in the evening, the windows can be open. And until 24 in the evening, they have to be closed. And I can now, because I've got control type temperature set here, I can now set a temperature schedule and say, okay, what temperature does the internal space have to reach before the windows open? And I'm going to make that a constant, so over all days, for all hours of the day, I'm going to say the window opens at 24 degrees Celsius. And that will apply to all the opening windows. So if I now come back into here, I can now export my context. But what I might do is I might go into ventilation link in my results, and I might select flow and opening factor. And now I might export that, and now press calculate. So I can now come into NV display, and I should now see the ventilation in that space in terms of ACH, and we might bring that down. So we can now see the flow coming into that space from our opening windows. We can look at, for example, the temperature within the space. So if I switch this to temperature, we should now see that we don't generally go above 24 degrees Celsius, which is when our windows start to open. If we want to check that our windows are opening, then because we have opening factor selected here, we could come in and I'm just going to add a v0.4 chart node. So create two axes. So I can now say linkage. I can pick a window and I can specify the opening factor. I can plot that and I can see when my window opens. So generally it doesn't open only opens in the summer when the building hits 24 degrees Celsius. If I was to come back into my MV network node and say, okay, it doesn't open at 24, actually opens at 20, then I now come in here, re-export, calculate. You can now see the window opens much more anytime the zone gets above 20 degrees Celsius. We can look at the flow, linkage flow in, for example, through that particular window. And again, we get a little bit of leakage flow through the window, even when it's closed, from the options within the subsurface flow node. Well, we can see now how much air comes in terms of meters cubed per second. Etc. So those are the basics of a subsurface flow node. We do also have surface flow nodes. So in, let's say, room 1, let's say that this wall has either a ventilator or a grill, or maybe just through fabric leakage, this flow surface can allow air to move through it. So what I might do is, this face has the material external walls. If I click plus next to external walls, I create a copy of external walls, and I'm going to call it external walls underscore AF. Now I can now make that underscore AF material an airflow surface. So that is a change in geometry. So let's export the geometry, and we can see that this zone node over here is now gone red. Now it's created some airflow sockets, but far more than I wanted. So I think what I have done is I've gone and specified this airflow surface to every wall face, which is not what I wanted. So let me just go to external walls, and what I actually have to do is I have to go into here, select this. I have to add a new material slot because I don't want airflow to go through all the existing materials. I just want it to go through this one. So I need to create a new slot in addition to the slot for these materials, and in that slot I can assign it, and I can now add my external walls AF with airflow surface selected. So now when I press geometry export, hopefully that limits the number of extra sockets I've created to 1. So just while I'm here, I'll mention this B at the end is boundary, S at the end is surface flow, SS at the end is subsurface flow. So I've now got this surface flow airflow link, and for that I need a surface flow node, which I've already got. So bring that up, drag that in, and I can say that this is either an effective leakage area or a crack. So I might go with an effective leakage area, say it's 0.1 meters squared. This doesn't require any control. This will just be open all the time and available to accept air ingress or egress all the time. So I'll keep those options as default. So now if I export that context, calculate, for example, now linkage EN room, it's not a window, it's EN room 1, linkage flow in, look at my linkage flow, which is more consistent all year round because this can't open and close depending on a schedule we set. This is just permanently there. So that's the basics of creating an airflow network. You'll notice that on each of these surface flow nodes, we've got node sockets on either side. If we are on a boundary, so say here, I could, if I wanted, on that boundary, I could specify that material as being an airflow material as well as a thermal boundary material. Then I will create my airflow sockets here, and I could, if I wanted, put this node between these two zones, and one node would connect into here, one node would connect into here, and then I can specify the airflow characteristics of that boundary between two zones. So we can control the level of flow, airflow occurring between zones as well as between the outside world and the interior of the zone. So I think that's more or less everything I have to cover. Okay, thanks for watching.